Okay, so I'm going to do an electron configuration, electron orbitals. I'm going to do one of the biggest ones. Actually, I'm going to do, you know what? Why don't I just do the biggest one? I'm going to go all the way through to Oganesson, number 118. Way down here, look down here. Okay, so in order to do that, we have to go through everything, and it gives you a sense of the sequence they occur in. Remember, electron orbitals are in blocks. So this is the s block. Okay, why don't I just write that? These two, is the s block. Notice that it's too wide, and helium is moved over here. So this is also the s block, but that's an exception, so I'm not going to label that. And then right here, okay, we've got what is called the p block. And then right here, from here to here, we've got the d block. And finally, we've got the f block. So maybe I should make every other one blue so you can see the difference. I do that one, there's the f block, and then you can see the difference. Also notice that the p block is 6 wide. Okay, so when we start off, we're doing the very, very first electron orbital. This is energy level 1. This is energy level 2. And then this is period 3, period 4, period 5, period 6, period 7. Notice how I stopped saying energy level, because actually energy levels don't always match periods. It's a periodic table. It repeats like days of the week. Okay, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's what we mean by periodic. And then these I'm going to use to help me out. I'm also going to put the numbers on this side. 1, 2, 3, 4, 5, 6, 7. So notice that we only have 7 periods at this point. With the periodic table, with all the elements we know about, we can fit them all in 7 periods and actually 7 energy levels. So I'm going to start off, let's see, I'll probably need a lot of room. I'm going to start off by writing it on the top, and then I'll have to probably continue it on a lower row. Let's see, could I fit it? I'm just going to start up here. Okay, so we start off with the first energy level, and it's the s block. So it's an s orbital, and I can fit 1 in there, or if I'm going all the way across to helium, well then I can fit 2, 1s2. Then, after doing that period, I'm done with the first energy level. Well, now I have to go to the second period of the periodic table and the second energy level, 2, which is also starting with an S. And if I go up to beryllium, up to here, well then that also has 2. Okay? So notice that the 1s has 2, the 2s has 2. All the s's, guess what, have 2. That's why the s block is 2 elements wide, because they can always hold 2 electrons. Okay? And remember, these electrons are being drawn in by the protons in the nucleus. So beryllium has 4 protons in the nucleus. That's why it needs 4 total electrons. Then, after having done this one, I'll just draw a line across. We go all the way over to here. This is where we wind up. Now, we are still in the second energy level. We're still in the second energy level, but now we're in the p block. This is a p. So 2p, and then if it had 1, if there was 1 there, that would take me to here. If it had 2 in it, if it had 2 in it, it would take me to carbon. Okay, notice that those would add up to 6, 2, 4, 6. That would match carbon. But I'm actually going for an element that is way down at the bottom. So actually all of these are going to get filled in. So remember, it is possible to have 2p1, or 2p2, or 2p3, or 2p4, or 2p5, but we're going all the way to neon, all the way to here and past it, so it's going to be 2p6. So that's the configuration of neon. Now we have completed the second energy level and the second period of the periodic table. Okay, so we have to go to the third. That's Aufbau, building up. Electrons don't really want to go in the third energy level, but they have to, okay, if the first and second are filled. So now we get to the, oh, do I have room here? I might have to start writing it over here. Okay, so now we're going to get to the third energy level. I wouldn't really leave a space like that in it, by the way. And this is also the s block. So that can also hold 2, 3s, 2 gets me to there. And look, it's kind of like deja vu. I'm doing the exact same thing I just did there, doing it again, and that gets me to another P block. But this is actually the 3P, okay, not the 2P. And notice there is no such thing as a 1P. So this is the 3P, and it can also hold up to 6. So I'm just going to fill it to get me all the way to argon, the lazy element. Okay, so now it looks like I've finished off the third energy level, doesn't it? Looks like I've finished it off, but I haven't. Remember, the third has 3, so it's got to have Sally's poor dog. It's got to have a dog. It's got to have D. But there's the D block, that's this, and we don't even hit the D block on the third period. So we're going to hit the D block later than we expect to. Okay? But if you read it like pages of a book, go to the next line. Well, obviously, this is the next, after number 18 comes 19. I get to here. So the next thing I'm going to fill is going to be this, which is the 4s. Okay, do I have room over here? Yeah, I have room over here. So this is the 4s, which can also hold 2. That adds up. If you add up these little numbers, they add up to 20 now. Okay? And then, now, finally, I run into this D block. But look where I'm running into it, on the 4th period of the periodic table. So you might be tempted to think that this is the 4D, but there is a 3D, I should say. There is a 3D, so actually, where's the 3D? Well, this must be it. So notice that even though this is the 4th period of the periodic table, this is actually going to be the 3D, and then of course this will be the 4D, the 5, and the 6D. They're all shifted down. They're depressed by 1, okay? So if this is the 3D, okay, let me put that here, 3D, not 4D, and then I wonder how many it can hold. Well, let's count. It's this wide, so count. Look here, how many does it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It can hold 10. So if we put in those 10, well then that gets me to, zinc. Guess what? That is where you have finished the third energy level. Right there. Isn't that weird? It's not on the end, it's right there. Okay, and then after we finish the 3D, well now we're back to the p orbital, but we already had the 3p, so this must be the 4p. 4p. And how many can p orbitals hold? Again, always 6. So that, I don't know if you can read that. That's a 6. Okay. So now we have gotten to here. And of course, when we go to the next line, it looks like deja vu all over again. Notice that the second and third period look very similar in their pattern, and the fourth and fifth look very similar in their pattern. So we can expect to see something very similar to that. So this, what's this going to be? You know. Well, it's 5. We've got 5. And it's the S block, so it's S. And how many can that hold? That can hold up to 2. So I'm going to put 5S2. And then dot, 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 dot. We cross over to here. But as we already said, this is not going to be the, this is not going to be the 5D. This is going to be the 4D. It's been depressed by 1. So now we're back into 4. And it's because the energy levels overlap a little bit. 4D. And again, if it gets me all the way to cadmium, then that can hold 10. Okay. Then I'm back into the P block. Well, what's the last P we had? Last one we had was 4. Well, this must be 5. This must be 5P. And how many can that hold? If we go all the way to xenon, that can hold up to 6. Okay? So notice there's been a pattern. The first period is kind of its own thing, and it has an exception on it. The second and third look similar pattern. The fourth and fifth look similar pattern. And look, the sixth and seventh, they have a similar pattern too. So now I'm going to go to, I think I'm going to go, I'm not going to squeeze it in there. I'm going to go down to this line right here. I'll start writing right there. So now we go to this. Well, what is this? You can tell me. This is the 6S. And if it gets me to here, oh, I'll use blue. If it gets me to here, I'm alternating red and blue. If it gets me to here, well then it's 6S2. Now we run into something we've never seen before. Oh, this is the F block, right? Oh, we finally get to the F block. Now, we haven't talked much about the F block, but we know it's going to be some kind of an F. Let's put an F there. But now, remember when we said Sally's poor dog flatulated? Sally's poor dog flatulated. So what's the first F going to be? Remember I said the first has 1, the second has 2, the third has 3, and the fourth has 4. So there is a 4F. It exists. This must be it. The first F we run into is the 4F. Now notice the 4F has been pushed down twice. It's been doubly depressed. Pushed down way to the 6th period. Now how many can an F orbital hold? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Can hold up to 14 electrons. Now that's complicated. If you want to see how that is, try to look up a diagram of F orbitals. It's kind of crazy. Okay, and that gets me all the way to here. So guess what? Where do we finish the 4th energy level? It's not over here, and it's not actually right there. It's right there. That's where we finish the 4th energy level, ytterbium, named after that little town in Sweden that has so many elements named after it. We'll talk about later if we have time. I hope we have time. And then, well, now we're back in the D block. So this is going to be a D. Let me not get confused here. This is going to definitely be a D. But which D would this be? Well, we've done the 3 and 4. Oh, this must be the 5D. And how many can a D orbital hold? Well, it can hold up to, just like the other ones, 10. So it doesn't matter that you're at a new energy level. D orbitals always hold the same number. P orbitals always hold the same number. Okay? Now we're back into the P block. And remember, the P block, the good thing about that is it's not confusing. P blocks match up to the period. So this is the 6P. The same thing that happens, this is the 6P, same thing that happens with the S block. So S and P blocks match up to their period. That's easy. And that can hold 6. That gets me all the way to radon. Okay, a very heavy gas that sometimes we have trouble with because it pools up in people's basements, in places that have basements, and causes damage from radiation. So now we're on the last period of the periodic table. So now we know we're on the 7th period. This is an S block. S's match their period. So this is 7S. And how many can an S orbital hold? S orbitals, if we get to radium, okay? Think of Marie and Pierre Curie for that one. Okay, 2. And then we're back to the F block, so I know this is going to be some kind of an F. This is where things are the most confusing, in the 6th and 7th period. But let's see, what's the last F I did? Well, this was the 4F. So what do you think this one is? This one must be the 5F. Okay? And how many can F orbitals hold? If we fill it all in, okay, it can hold, oh yeah, 14. We already counted. By the way, you knew this had to be an even number, because if you can ever fit one electron with one spin, you can always fit the other electron with the opposite spin. So electrons can never, whenever one electron can fit, you can always fit 2. So you knew that, notice all of these numbers need to be even numbers when you fill up an orbital. Okay, so now we've gotten to here. Now is that where we finish the 5th energy level? Well, so far it is, but there could conceivably be more later if we discover new elements. So let's not say that. I'm not going to go ahead and say that, because other elements can be synthesized. A lot of the elements, by the way, after here, these are called trans-uranium elements. These are almost entirely synthetic. The only exception is plutonium that they found naturally now. These elements are man-made. They're made in laboratories. So they don't usually last too long. Some of them have uses like in smoke detectors, okay, which we need right now with all these fires. Okay, so 5F14, we're here. Now we're back to the D block. So we know that's going to be a D. Don't confuse yourself. Look at what the last D you had was 5. This must be 60. So remember, the D block has been pushed down by 1, and the F block has been pushed down by 2, which is why we get these weird numbers. We get 7, then we go back to 5, then we go back to 6. Okay? And now we're in the very last orbital of the whole periodic table, right here. Well, that's easy, because we're in the 7th period. Oh yeah, by the way, the D block can hold 10. Okay, and that gets me to Copernicium. So we're in the 7P, because remember, P orbitals match their period. If it's in the 7th period, it's the 7p. And that can hold 1, 2, 3, 4, 5, 6. That gets me all the way to Oganesson, which is 118 on the periodic table. Okay, so that is the largest element that we've synthesized so far. And where would 119 go? That was one of the questions on your homework. Okay, 119 would have to go not here, it would actually go right there. Okay, 119 would go there. And then if we get 120, then we'll probably discover after 120, we'll probably have a whole new orbital that would open up and spread the periodic table out even wider. So that's how you do one of the hardest electron configurations. Anything else is shorter, anything else is less than this. Okay, here's your example.